So now we're going to do a different type of counting. We're now going to be doing path counting. So the rules are always going to be, essentially... Now I've pre-drawn the diagrams for this because it takes me forever to draw these normally. So, the rules are generally going to be that we're going to start at A and go to B. Let me just write these down. So we're going to start at A. We're going to end at B. And the other rule is going to be that you can only move right or down. So you can only move to the right, and you can only move down. You can't go dunk, 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 dunk. That doesn't work. You can only move right, you can only go down. And so we have A to B, and we want to know how many ways there are. And for all of these, I would pause the video, try to figure it out yourself, and then start it again and see if you got the right answer. So in this case, we could either go down, right, right. We could go down, right, right. Or we could go right, right, down. So that's one way. That's the second way. Or we could go right, down, right. So that's A, that's the B. Right, down, right. And that's it. So there's a total of 3 ways. So there's 3 ways to get from there to there. We're going to come back to this one in a second. Let's look at example 2. So same idea, we want to get from there. So there is going to be, we could go right, right, down, down. We can go right, down, right, down. We can go right, oops. We can go right, down, down, right. So go right, right, down, down, right, down, right, down, right, down, down, right. And then we could do the symmetrical ones going down first. So we could go down, down, right, right, down, right, or down, right, right, down. And that's it. There's a total of 6 ways to do that. So there's 6 ways to get from A to B. Okay, we'll come to that. We'll come back to that in a second. Example 3. Yeah, and this is going to take a little bit too long. Like counting all the paths to get from A to B here, we're not going to write them all out. That's not going to work. We need another way of doing this. Let's go back to this one over here. Let's go back to the first one. So what we know is we could see there's only, if I want to get there, there's only one way to get there. So there's one way to get to that corner over there. And there's one way to get here. Now if I want to get to this point over here, I could go like this, or I could go like this. So there's 2 ways to get there. If I want to get to there, there's only one way to get there. And as we saw, there's 3 ways in total to get over there. Now if we look at these numbers, what we see is that there's 2. There's one way from there, one way from there, and that's 2. There's 2 ways coming from there, and 1 way coming from there, and that's 3. So each vertex, essentially, of the path is the sum of the paths that lead to the ones that feed into it. So let's try it with this one over here. We know the answer should be 6. So there's one way to get there and one way to get there. There's one way to get there and one way to get there. One way there, one way there. That's going to give us a total of 2 ways to get there. 2 ways there, 1 way there. A total of 3 ways to get there. Which we kind of already knew. That's the previous shape that we had. 1 way there, 2 ways there. So there's 3 ways to get there. And then 3 ways and 3 ways makes a total of 6, which was the answer. We had actually figured out through brute force that it was indeed 6. Okay, so let's try it for this big one now. So I draw it out. Make sure you count the right number of lines. Pause it, try to figure it out yourself. I'm going to go through it. So there's one way to get there, and one way to get to all of those. 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. 1 and 4 is 5. 5 ways one way, 6. 2 and 1, 3. 3 and 1 is 4. 4 and 1 is 5. 5 and 1 is 6. 6 and 1 is 7. Okay. 3 and 3, 6. And if you look, that's just the 2x2 grid that we had before, right? Nothing very special about that. So that's going to be 10 and 10. 15. 15 and 6 is 21. 20, 35. That's going to be 56. It's possible I'll make a mistake on this. If so, just let me know and I will. You might want to check the comments to see if I've put any adonyms in there. 35 and 35 is 70. 56 and 70 is 126. These numbers are getting big. 15 and 6 is 21. 35 and 21 is 56. 70 and 56 is 126. This is going to be 28. I think we're in calculator land here. 56 plus 28. 84. That's going to be 210. This is going to be 252. And 252 plus 210. And that's going to be 462. And that's kind of crazy. There was no way we were going to actually count that 462 paths. But using this kind of technique, we could figure it out. What's going on? For those who know, you don't have to know this, but if you know something called Pascal's triangle, this actually is Pascal's triangle kind of on site. It's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Each one of these kind of diagonally is a row of Pascal's triangle. But as I said, we're not doing that in this lesson.